Welcome to the Silicon Valley VLSI Vision Academy. Today I will present to all of you how to do synthesis for synthesizable Verilog code using Cadence Genus. So first of all, let you know about what is synthesis. Synthesis is a process of generating gate level netlist from the functional verified Verilog RTL code. So let's start our synthesis lab work. First of all, we need to go to our work directory. So I'll go to my work directory to do synthesis. My work. So okay, to do synthesis using Cadence Genus, we need some files like library files, constraints, and one Verilog code, which is actually functional verified. So if I show you the my library file, we can see under lib there are four like two library files basically. So we use for here for the synthesis first library, which is name is first underscore bdd1 b0 underscore basic cells dot lib. uh, and then if I show you the constraints, which name is constraints underscore dot constant underscore top dot stc, and if I show you the functional verified Verilog code, which is actually will be synthesized. This is our functional verified Verilog code, which actually will be verified using the Cadence genus. So okay, now go to the work directory and see that on a TCL file dot TCL file. Uh, uh, so I made a TCL script as I will do synthesis using the source command. So if I show you the my TCL script, which is actually this is our TCL script. First we need to set the path. So first we set the library path, which is actually I use here the relative path. This one means the first go to the previous directory, and library path is inside the lib directories, and the SDL file is it. I also use here the relative path. So it means it goes to the previous directory and goes to the Verilog directory, and then it finds the SDL files. And the second one is read the files. So for the lib files, it reads the first technology file. It make basically first underscore bdd one b0 underscore lib basic cells dot lib, and the read STL files, which is actually this pp underscore at underscore 32 bits dot b, which is from the our design code, and this pp underscore at underscore 32 bits, which is from the name of the top module names. So and here we will elaborate our design using the elaborate command, and we apply the constraints. And so it means read the our SDC files, and I also here used the relative path. So it goes to the previous directory and goes to a constant and read the constraints underscore top dot SDC. And for the synthesis effort, for three type of synthesis effort. I used here high for like sync generic effort is high, and sync map effort high, sync of PT means optimization is effort is also high. So and the synthesis steps, first of all it generate the generate the generic, and then it will be create the map, and then synthesis will be optimized here. So and for the analysis, the design, the timing report, power report, area, and quality operated QOR.rpt will be generated under report underscore dot I directory, and the design will be export like netlist, SDC, and constraints under output underscore high directories. So now we need to quit from here. So we need to start our synthesis. We need to set our environment using the css command, and we need to call our genus using genus command. Ah, okay. We need to wait a few seconds. Okay, using the source command, I'll call my tcl script. Okay, now press enter. Okay, the tcl script is synthesis is running. Yeah, the unit. Okay, okay, it's finally it's complete successfully. So if you want to show the schematic view, you need to write the command like GUI underscore show, and we can see the schematic view in main, and you can see the schematic view is here, present here. Okay, then to analyze our report, and we need to go to our work directory to analyze our reports. So first of all, I'll show you the our reports. So uh, I'll go reports, and if to show you the my power report, you see the power report are generated here, and you can see the all of the power informations. Uh, uh, in the same way, you can see the area report, quality of report, and timing report. And if I show you the output export general design export under outputs high directory. Mm, if I show you, I want to show you the netlist file. Mm, see, here is the get enable netlist are generated here. In the same way, you can see the constraint file, uh, LSDC file. So that is all from today's class. Thank you.